So in this slide, we're gonna discuss two things, serial dilution and calculating for the concentration of ions in solutions. Okay, let's first begin with serial dilution. So here you have a sample of indigo, a dye, which has been diluted 2 times. Okay, now when I approach serial dilution problems, I usually write diagrams or draw diagrams so that it's easy for me to see what's happening. So this information that you have 100 ml of the sample of indigo really um, doesn't really matter what that what that volume is. We'll see later why. But anyway, for the first solution, so you have a molarity equal to 0.36 molar. And you know what? Sure, let's actually put here that this volume is 100.0 ml. Okay. And then after that, we took 10 ml of it. Okay, and then diluted it to 100 ml. So the new volume is 100 ml again. Okay. And the new concentration is, well, unknown. Okay, and then that solution of unknown concentration, you once again diluted it by taking 2.00 ml. Okay, you now don't know what this concentration is, and that's actually what you're trying to find. And here, the final volume was again 100 ml. Okay, so what I like with M1V1 is equal to M2V2 is as long as the units are consistent with each other, I don't really have to convert liters to milliliters to liters or whatever. Okay, so let's try to work first on this one. Okay, so according to this one, we had a new volume. Okay, or sorry, we had a new molarity after we took this volume from this concentration. So if this was step 1, so it looks like M here should be our M2. Okay, and then this volume, how much we took basically from the original solution, should therefore be V1. Okay, and then this one should be the original molarity, and the V2 should be the final volume of the new solution, so it's this one. So as I did say earlier, we don't really need this volume, okay, because the only thing we're concerned with is how much did we get from the first solution. Okay, so if we do this for case number 1, so that's M1 V1 is equal to M2 V2. Okay, we solve for M2. Of course, you can rearrange this equation for solving for M2. That will be that will be M2 is equal to M1 V1 divided by V2. Okay, so here M2 is just 0.36 molar, that's M1. Okay, times V1. Again, I don't really need to convert. As you will see later, the units will cancel out. 100 ml, or sorry, this is 10 ml, not 100 ml, so there's a dot there. Okay, 10 ml divided by the new volume V2, which is 100.0 ml. Okay, and this will just give you 0.036 molar. Okay, neat. But again, that 0.036 molar of solution, we actually had to dilute that. Once that solution was prepared, you took 2 ml of it. So this one for step 2 is now the new V1. Okay, this molarity, which was unknown and is now known to be 0.036 molar, okay, is now M1. Okay, 100.00 or 100.0, that's just 10, sorry, is still V2. I mean, it's the same volume, and we're still solving here for M2. Okay, so for step 2, the same thing, we can use this equation. So M2 is equal to, therefore, here M1 is the one we previously just used, solved rather, 0.036 molar times 2.0 ml divided by 100.0 ml. And I forgot that to actually show you that, so you can see ml will cancel out, so we're just left with molarity. Okay, so here M2 should be equal to 7.2 times 10 to the negative 4 molar. Other ways to actually write this, remember that we can also express this with SI prefixes. So you might also want to write this as 0.72 millimolar. Millimolar is also a unit of concentration. Well, milli just means times 10 to the negative 3. Okay, or another way to express this, which I actually prefer more, will be 720 micromolar. Although that the one does not follow the rules of sig figs. But that's it.